Okay, let's dive right into this. We are looking at arguably the greatest astronomical plot twist of the entire 21st century. I mean, it's a story that literally captured headlines around the globe, sparked these fiercely passionate debates among scientists, and actually forced us to rewrite our science textbooks. So today in this explainer, we're going to unpack the completely fascinating scientific journey that led to the infamous demotion of Pluto. For over 75 years, Pluto held this incredibly special place in our cultural consciousness. If you grew up before 2006, you absolutely learned some mnemonic device about 9 pizzas to remember the planets, right? With little Pluto hanging out there in the freezing dark. It was just an undisputed foundational fact of our solar system. But then, in 2006, boom, it officially loses its status as a major planet. So what actually happened? Did it shrink? Did it just wander off? Or did scientists seriously make a colossal mistake for 3/4 of a century?
Let's move to the timeline and see how this all builds up. To really solve this mystery, we've got to rewind back to 1930 at the Lowell Observatory. A young American astronomer named Clyde Tombaugh spotted this tiny, faint point of light moving against the backdrop of the stars. And because it was large, it was nearly round, and it was orbiting the sun, it was enthusiastically crowned our 9th planet. But human technology doesn't just sit still. Fast forward to the early 2000s, and our incredibly powerful new telescopes were about to bring a massive revelation to the table.
And that revelation is what astronomers now call the Kuiper Belt problem. See, as we turn those advanced telescopes toward the very outer edges of the solar system, we realize something stunning. Pluto was not alone. Far from being this solitary wanderer out in the deep dark of space, Pluto is actually sitting smack in the middle of a massive, crowded, icy debris field. This region, known as the Kuiper Belt, is this vast area way beyond Neptune, and it's just filled with icy objects, ancient asteroids, and all these small worlds left over from the formation of our solar system. Suddenly, Pluto wasn't just the 9th planet. It was actually a member of a huge, previously hidden population of celestial bodies.
Now, what's really interesting about this comparison is how it created a full-blown crisis. In 2005, the astronomical community realized they had a serious problem on their hands with the discovery of an object named Eris. And here was the kicker. Eris was also sitting out there in the Kuiper Belt, and it was actually slightly more massive than Pluto. This gave scientists a massive headache. Because think about it, if Pluto is a planet, shouldn't Eris be one too? And what about the dozens of other similar objects we were suddenly spotting? We were literally looking down the barrel of a solar system with maybe hundreds of planets.
So, to solve this escalating crisis in space, an organization called the International Astronomical Union, or the IAU, had to step in. In 2006, astronomers from all over the world gathered to do something highly ironic. They had to formally write down the scientific definition of a planet. I mean, think about that for a second. We've known about planets, we've used that word for thousands of years, but there had never actually been a strict, universally agreed-upon set of rules for what makes a planet a planet. To prevent the solar system map from descending into absolute chaos, they desperately needed to draw a definitive line in the sand.
So the crucial point is this new checklist. To prevent all that orbital chaos, the IAU established 3 strict conditions for planethood. Condition number 1, it must orbit the sun. Check. Pluto passes easily. Number 2, it must have enough mass for its own gravity to pull it into a round shape. Again, check. Pluto passes with flying colors. But condition number 3, that one requires a planet to clear its orbital neighborhood, meaning it has to be the gravitationally dominant object in its path. And because Pluto sits inside that densely packed Kuiper Belt we talked about earlier, it utterly fails this final test.
And because of that one specific rule, Pluto was reclassified. But here's the thing. It wasn't destroyed, it wasn't cast out of the solar system, and it certainly wasn't deemed unimportant. It was just reborn into a highly specific, brand new scientific category, a dwarf planet. It's simply a world that orbits the sun, it's round, but it just hasn't cleared out its neighborhood. Honestly, it's a perfectly tailored classification that allows us to accurately group Pluto with Eris and all those other incredible worlds.
But while the IAU was busy changing Pluto's label on paper, something far more magical was happening out in deep space. In 2015, NASA's New Horizons spacecraft finally arrived at Pluto after a whopping 10 years of travel. It became the first mission to ever visit this distant world, and it started sending back these gorgeous close-up photographs that completely, totally shattered our expectations of it, just being this dead, cratered ball of ice.
New Horizons revealed a world that is shockingly vibrant and incredibly complex. I mean, scientists found a thin, hazy atmosphere and towering mountains. And get this, they aren't made of rock, they are made of solid water ice. And famously, they captured images of this giant, incredibly smooth, heart-shaped glacier.
They named it Tomball Regio, in honor of the astronomer who first discovered the world. The data even suggests the thrilling possibility of a liquid ocean hiding deep underneath its crust. No way is this just a boring rock.
And this brilliantly illustrates the main takeaway here. Look, not all scientists agree with the IAU's new classification, even to this day, especially given Pluto's unique geological complexity. But what nearly everyone does agree on is this: Pluto didn't change. Our understanding of the solar system changed. Science isn't just a static list of memorized facts you learn in grade school. It's a continuously evolving pursuit of truth. When new evidence, like the Kuiper Belt, appears, we adapt. We update the models.
Which really leaves us with a thrilling question to ponder as we wrap up. If looking closer at our own cosmic backyard forced us to completely rethink the very definition of a planet, what else is waiting out there? As our telescopes get sharper, as we look deeper and deeper into the cosmos, what other fundamental facts will we have to redefine? The universe is unimaginably vast, and honestly, our journey of learning is really just getting started.